We can relate molecular structure to acid strength for certain substances, and take a look at this and see if the explanations make sense to you. If you have an oxo acid, that is perchloric acid or some acid that contains oxygen, you're going to have the same central atom, but you'll have different numbers of attached groups. If you want to figure out which one of them are stronger, we'll just realize that as the oxidation number of that central atom increases, the acid strength will increase. So let's take a look. Here's hypochlorous, chlorous, chloric, and perchloric acid. Every single one of these is an acid. But notice that as we go to perchloric, the chloride ion achieves a oxidation number of +7. And you can use that as a rationale to find the relative strength. It's nice to memorize that perchloric acid is the strong acid in this case. It's on our list. And so you can do it that way and then work your way down by looking at the oxidation number of each central atom. Therefore, perchloric is stronger than, chloric is stronger than chlorous and is stronger than hypochlorous. So those names can be a pain. Let's try the relative strengths of these three. Now this is designed to be a little more challenged because if you look at the central atoms, they all have an oxidation in number 1. So it's just Cl versus Br versus I. Now we learned that hydrofluoric is a weak acid, so they're getting stronger as you go down. But let's see if it's going to hold up. Let's consider, right? The electronegative decrease from chlorine to iodine. The electronegative decreases as we go from chlorine to iodine. That means the chlorine atom will be attracting the electron pair as it shares with oxygen to the greatest extent, and therefore things flip around. The O to H bond is the most polar in HClO and the least polar in HIO. So it follows the reverse order from chlorine is stronger and bromine is stronger than iodine. Without the O, it goes opposite. Nitric versus nitrous acid, well, draw them out. And maybe we can take a look at the formal charge. That's the first thing to do. And you'll see it's +3 in nitrous and +5 in nitric. And so therefore the nitric is stronger than nitrous. It helps to memorize that nitrous is a weak acid and nitric is a strong acid.